Hi, today I'll be coding something that evolved from the previous demos that I did. So this is what I did last time, and it's a hexagon ring made out of triangles. What I will be coding today is a hexagon grid made out of triangles. So basically I'll be filling the inside of this ring with triangles. Let me show you how it would look. So if the ring is just this outer part, then I would fill it with these 6 triangles that form a hexagon. Now we will be having more layers because here we only have 2 layers. So the inner layer is this hexagon in the middle, and then we have this hexagon ring around it as the second layer. So 1 layer, second layer. We will be having more layers, and then we will be animating these triangles up and down in a spiral fashion. So let me show you what that looks like. If you are a patron on Patreon, thank you, and you may have already seen this. And I'm really happy because it's done with CSS, and it's really cool. So let's get started. We are going to start with a number of layers, and this is going to be actually equal to the number of segments that we divide the outermost hexagon edge. So let's say it's going to be 4 in the beginning. We're going to increase it a bit later. Then we're going to compute the number of triangles that we have in a hexagon slice. So let me show you. Here you can see how a hexagon is being built, and it's made up out of 6 slices. So we have 1, 2, 3, 4, 5, 6 slices, and each of these slices can be divided into triangles. So something like this. And how many triangles we have in such a slice? Well, it depends on how many layers we have. So here we have 10 layers, and as you can see here, it's divided, the outermost edge is divided into 10. And when we have 10 layers, it means that we have 100 triangles. So how do we know this? Well, on the first layer we have 1, on the second we have 3, so 1, 2, 3. On the third we have 5, 1, 2, 3, 4, 5. And this is basically the sum of the first 10 odd numbers, 1, 3, 5, then 7, 9, and so on. And the sum of the first n odd numbers is n squared. Okay, so that's how we know the number of triangles in a slice. So let's compute that. This is going to be the number of triangles in a slice, and it's m squared. And then the total number of triangles for our hexagon grid is going to be n, the number of triangles in a slice, times the number of slices, which is 6, equal to the number of edges, which we should have already set. So let's set it. Okay, so now that we've done this, we can move on to creating the triangles in a loop. So for I going from 0 all the way up to n, incremented at every step, we're going to have a triangle element, and in its style attribute we'll be setting an index, and this is going to be its index on the grid. So every triangle on the grid is going to have a unique index, and it's going to be this value. Okay, now having done this, we will be setting a few things here. So we're going to have some things on the body, right? And then in a loop we are going to be setting something for each layer, and that's going to be its layer index. So how do we know just how far off we are? Well, so this is up to the number of layers m, right? And then we're going to have triangle nth of type. we cannot use nth child because we have the style before. Okay, so that's the reasoning behind. So now we need to have we're going to have this p number, but it's only going to be up to the current layer. So it's going to be I times I, right? And then it's going to be times the number of slices, and of course plus 1, because indices for nth child are 1 based. And it's just now that I'm seeing that I can't type. So here we'll be setting the layer index, and this is going to be equal to I. And actually we're going to start this from 1, right? And here what we'll be setting is a layer. This is going to be the default 0, and of course we'll be setting M, and in the same way we'll be setting N and Q, and I don't think we need to set P. So I believe we're all done here. If not, we'll come back to it. Now what we want to do here is set these triangles, and we're going to start with a circumradius for the triangles, and this is going to be something like this. We can tweak it later. And we're going to set a padding to this. Let's just set a random background. Okay, that's now let's actually, we're going to take all these styles from here. We'll just actually we don't have any other divs other than the triangles, so hold on to that. So we're going to have the exact same thing here, right? Display grid. We're going to set these grid area, make sure place self center, right? And okay, this should have been should have done it, but for some reason it didn't. So let's see what's happening here. Okay, so we have the body and we have these triangle elements, and of course they have grid area, right? Oh, the background is also black. That's the problem. We're not seeing the contrast. Anyway, that was silly of me. Okay, so we've created these, and we're going to include the polygon. So now we should have a triangle here. Oh yeah, we need to import compass. So now that we've done this, it should work, and it does. As you can see, we have that nice little triangle there. Okay, so cool. Now it's time to move on to the more interesting stuff. So that's going to be transform, right? So we're going to set transform to position them on a grid. Okay, so first off, as we did before, scale 0.9, and then we're going to want to have an edge index, just like we said last time. So in order to compute that, we need to compute a few other things before. So for each of these, we're going to need to compute the number, this number p, for up to the current layer. So this is going to be twice the layer. So this is going to be the number, just like last time. This p is the number of triangles per edge for the current layer. So it's going to be, so the number of segments on the outside is equal to the number of the layer. So that's going to be twice the number of segments minus 1. And in this case, it's equal to the number of the layer. So twice the number of the layer. And in this case, it's going to be plus 1 because the index is 0 based. So we need to up it with 1. Okay, so having done this, we're going to compute the number of items that we have on the previous layers. So the total number of items that we have on the previous layers. And this is going to be a calc, and it's going to be the number of edges, which is q, times the layer index, and again times the layer index. Now for the first layer, it's going to be 0 because the layer index is 0. Then we're going to have 1 times 1 times the number of edges, 6. We're going to have 6, which really makes sense. Where is this? So for the first layer, which are these 6 triangles, we're not going to have any triangles before them because these are the first. For the second layer, which excludes these 6 in the middle, we're going to have 6 before them, and so on. For the layer after them, we're going to have these ones. So that's going to be 24. Okay, so having done this, we're going to compute a relative index. And this is going to be the current index, which is unique for every triangle on the grid, minus the number of items, the total number of items, triangles we have on the previous layers, on all previous layers. Now, having done this, we can, so we know the index on the current ring, so we know the index on this current ring. Now that we've done this, we can compute the edge. So we're going to compute a k value, and this is going to be calc, and here we're going to have the index for this current ring, right, over p, the number of triangles we have per edge, right, and just to make sure we have the floor, we subtract 0.5. This is going to give us the possibility to have something below 0 at the very beginning, so we're going to have max between 0 and this. And now, of course, we'll be needing to do something like this, register this. So we're going to register this, and this is going to be k. So now that we've done this, we can have a rotate here, and we're going to have calc k over the number of edges, so the edge index over the number of edges times 1 turn. So this should rotate stuff, and as you can see, it does. Now the next thing we want to do is compute the index on the current edge. So now that we've done this, it's going to be j, this is the index of the triangle on its current edge. It's going to be calc, its relative index, minus the edge index, right, times the number of triangles per edge. So this is going to be its index per edge. So now that we know this, we know how to position it along the edge, right? And we should also know how to position it in the other direction, because we know the layer index. So let's translate. So along the edge is going to be the first one, and we're going to get to it soon. But now let's move on to the second one. So this is going to be we're going to have the height times the layer index plus the circumradius, plus once the circumradius. So the height, let's get back to this a little bit. So we have, in a triangle, the number of edges is going to be 3, right? The base angle is going to be 360 degrees over the number of edges, right? And then we're going to have the in radius. This is going to be the circumradius times cosine half this base angle, right? And then we're going to have the height, which is the circumradius plus the in radius. And we can also compute the edge length, which is twice the circumradius times the sine of half the same angle. Okay, now having done this, we can get here, and we're going to have, so basically the layer index times the height plus the circumradius. Okay, so it's starting to look like something, as you can see, and now we have to move on to positioning them along the other direction. Okay, so this is going to be another calc, right? So this is going to be, actually we're going to go in the opposite direction. So we're going to have 0.5 times the layer, right, minus the index per edge. Okay, and this is going to be times, this is within the calc, right, the edge length. So let's see. Okay, they're nicely distributed, and now we have to reverse, as you can see, those even items. So we have the odd, so basically odd indices, because we're going to have 0 and 1, and the odd indices is what we need to reverse. So basically this is going to be exactly just like last time, so exactly the same thing. So like we did here, it's basically the modulo 2, and of course we're going to need to register, we're going to need to register that as well. So it's going to be the integer, right? Let's move on here, and we're going to have rotate, and we're going to have the modulo times half a turn. Okay, and now we have to translate this by the in radius. So we're going to have to translate in radius. Translate y, sorry, vertically. Okay, the other direction, like this. Though that's not a bad effect either. Okay, now having done this, we're going to want to have some sort of spiral effect, right? Animation. But first, let's just create the animation here. So it's going to be pretty much the same. I think we can just copy it. Pretty much the same, yeah. We're going to set a position. So position, and this is going to be the position minus this scale. So the transform is going to be in the position and scale 0.9. Okay. Now, having done this, let's also set an animation duration of 1 second here. And we're going to set here, right, animation, what was this called? Okay, easy out, infinite, alternate, all right? Okay, so it looks like something. Now, what we can do here is set an animation delay. That makes things a bit more interesting. So this is going to be basically something like a calc. And we're going to have something multiplied with minus the animation duration. So first off, let's say it's going to be the number of layers over the total number of layers, which is going to be m. Right, something like this. As you can see, it looks like something, right? And we can add this up to something like k over the number of edges, right? As you can see, it's already starting to look like something. But to this k, we can add the current index on the edge over the total number of triangles per edge. And we're going to get something like this, right? And it's going to look a lot more interesting if we increase this number. Right, or we could do something. A bit more interesting, I'm thinking. So, for example, we can do k. Twice the animation duration. Let's see how that works. And we can subtract this, and we can subtract a further one. Let's see how that works. Okay, this looks much better. So yeah, this part is actually just a lot of tweaking and just figuring out which direction looks better if the animation goes in. So yeah, that's pretty much it for that part. Now, something else we want to do is an HSL value, and this is going to depend k, so the edge index, over the total number of edges, times 360, something like this. Let's make it 100%, 50% for now, okay? And here, of course, we can adjust this and have the same j over, so the current index on the edge over the number of items per edge. So you can do something like that, and it looks better. But it's going to look even better if we do something, because there you have quite a sharp contrast. So I can do something about the luminosity. So we're going to have something like this. Calc, basically 1 minus the layer index over the total number of layers, right? And everything multiplied with 100%. So that's going to be the lightness. Okay, so yeah, that's pretty much the desired result. I hope you've enjoyed this video, and if you like the work that I've been putting out for more than 8 years now, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon. The link is going to be in the description, or you can get me something off my Amazon wishlist for Christmas. Again, the links are going to be in the description, as well as the links for everything referenced in this video. Or you can at least share this to show the world what can be done with CSS these days, because honestly, I think it's pretty damn cool. In any event, thanks for watching, and until next time.